Hey guys, I want to go over for a few minutes the matrix multiplication topic that we covered in class recently. I know it can be kind of tricky, especially if you're first starting out with it, but don't worry, you'll get the hang of it. Okay, we're going to use an example here. All right, we're going to let matrix A equal 3, 2, 1, 4. Matrix B, -1, +2, 3, and 5. Okay, we want to multiply these two together. Now, these we know we're going to be able to multiply together because of the same dimensions. But in case you're ever confronted with matrices that have different dimensions, what you do, take the dimensions of the first one, in this case it's 2 by 2, and check the second one, which is also 2 by 2 in this case, and look at the middle dimensions here. If they match, that means you can multiply them. Alright, so here we know they match. Here, these numbers will give us the dimensions of our answer matrix. Okay, so this will be the product that we come up with. So if you multiply a 2 by 2 and a 2 by 2, you get a 2 by 2. Okay? It won't always be the case that you'll end up with one of the same dimensions that you started with. So if you have a 3 by 2 and a 2 by 3, you're not going to end up with that. Okay? So what I'm going to do is I'm going to create a little bit of scratch paper. Okay, it's just an area for me to work and keep my thoughts straight. I'm going to label it. Label 1, 1, 1, 2, 2, 1, and 2, 2. These numbers stand for the row of column 1, or the row of matrix A, and the column of matrix B that I'm working with. Okay, the row comes first, the column comes second. So if I want row 1, column 1, I'm going to take row 1 and column 1. Okay? I'm just putting these marks down as a way to keep track of what I'm doing. So I'm going to take the numbers 3 and 2 from matrix A. What I'm going to do is I'm going to multiply them by corresponding terms in matrix B, but using the column instead of the row. So 3 will be multiplied by -1, giving us -3. 2 will be multiplied by the second term in our column, which is 3. So we have -3 and 6. Now with these, we're going to add them together. So we add -3 and 6, which gives us +3. So when we go ahead and start creating our answer matrix, our first element is going to be 3. Now, I'm going to change colors so hopefully y'all can see this a little bit better. We're going to stick with row 1 of matrix A. Now we're going to move to column 2 of matrix B. Okay, so row 1, column 2. So we still have 3 and 2 from matrix A that we're working with, but now we're going to use 2 and 5 from B. 3 times 2 gives us 6. And 2 times 5 gives us 10. Now again, we add those numbers together, we get 16. So if we go ahead and put this answer in our matrix, we have 3 and 16. Alright, we're going to change colors again. Now we're moving down to our second row in matrix A. Notice the first number in these have changed. They're now 2. Represents the second row of matrix A. So we're going to use 1 and 4. Well, we're going back to column 1 in matrix B. So we're still here. Okay? So we use -1 again and +3. 1 times -1 is -1. 4 times 3 is 12. We add those two together and get 11. So entry 2, 1, row 2, column 1 is 11. One last one to take care of. We're still on row 2 of matrix A. Now we're going to switch to column 2 of matrix B. So we have 1 and 4. And now we're going to use 2 and 5 again. So 1 times 2 course 2. 4 times 5 is 20. We add those together, we get 22. This is the last entry in our product matrix. Okay, so it's a little complicated. All right, it's not as simple as addition and subtraction, where you just simply add or subtract the corresponding elements. You have to keep track of rows and columns and individual terms and sums and products. So it's a little bit complicated. But if you have something to keep your thoughts straight until you get real good at it, this is a good way to do it. All right, so if you have A and B and you multiply them together, you get your product matrix. Okay, hope this helps, guys, and just keep following the same steps over and over. All right, no matter what dimensions your matrices have. Okay, you should end up with the same kind of answer. Okay, all right, hope this helps, guys. See you later.